Greetings and welcome back. Today we'll be doing a very brief introduction into the functional group amines and also looking at how to name them. In general, amines are functional groups in which we have a nitrogen with 3 single bonds and a lone pair. Depending on the number of hydrogens or carbons that are directly attached to that nitrogen, we classify them slightly differently. So for example, if all 3 of those are hydrogens, then we call this ammonia. And if you have 1 carbon and 2 hydrogens, we have 1 carbon attached, so this is called a primary amine. If you have 2 carbons attached, those could be the same or different, and 1 hydrogen, we call this a secondary amine. This is very similar to how we name primary, secondary, tertiary, etc. When we do alkyl halides and alcohols and things like that. Except in those cases we're talking about the first carbon attached. In this case we're talking actually about the nitrogen itself. So how many R groups are attached to that nitrogen. Alright, if you have 3 R groups attached to the nitrogen, and again they can be the same or completely different things, this is a tertiary amine. There is also a case in which you could have 4 R groups attached. And I'll just write all of these as R, but you get the idea. They could be the same or they could be different. In this case, that nitrogen will have a plus charge. It no longer has a lone pair. This is sometimes called a quaternary amine, often referred to as a quat. It's always going to have a positive charge, so in general this will be part of a salt. So you would have something like maybe a Cl- hanging around in order to make that guy neutral. Alright, so this is generally how we classify them, but the reactivity of amines is almost completely determined by their presence of that lone pair. That lone pair in general can be either to grab away a hydrogen, so here we'll do it this way. If you have, say, a hydrogen attached to some acidic molecule, in that case this guy would be acting like a base. Or alternatively, well, that would kick those electrons over. Alternatively, you could have it attack a nucleophile, or sorry, an electrophile. So that would be in the case of something like CX. This guy could act like a nucleophile, attack that carbon, kick off the leaving group. In this case, it would be a nuke. So just like anything with lone pairs, it can act like either a base or a nucleophile. And just like anything with lone pairs, the acid-base reaction tends to happen much more quickly than the nucleophile-electrophile reaction. So I would say that this is your kind of first reaction, is that it's a base. And the second thing that will happen is that it would act like a nucleophile. Alright, so just a brief introduction to how we'll present all of this information. We'll talk about naming in this lecture. The next lecture will be about how it acts like a base, which is what I have described here. And then in the next few we'll look at kind of how to synthesize these and how to break them down at the same time, or react them at the same time. Because you need to start with an amine to make an amine, so there isn't like a nice discrete set of reactions to synthesize them and then reactions to kind of react them. Instead, all of that just lumps on in together. Alright, so let's move into nomenclature. The IUPAC way of naming amines is to replace that last E with the whole word amine. And just like alcohols or ketones or whatever, you need to put in a number of where it is located. So for instance, if you were to look at this molecule, it is a 5-membered chain, carbons 1, 2, 3, 4, 5, and we would call this 2-pentanamine, because we would write pentane and we'll replace that last E with the word amine. Of course, you could put the number inside the word, so this could be pentan 2-amine. That is the general starting point from which we name these. If you have a substitute, so basically this is your main chain, is all of this stuff. if you have a substituent on that nitrogen, so for instance, let's go with something like this, you would have to rank these carbons, right? So the longest chain with the nitrogen on it would be 1, 2, 3, 4, 5, 6, and this would be our main chain. It would include that nitrogen. So in this case, we have an ethyl group, but it's not on 1, 2, 3, 4, 5, or 6, it's on the nitrogen. So if your nitrogen is part of the main chain, we basically number that location as N. So just like you could have an ethyl group at 1, 2, 3, 4, 5, or 6, if your main chain is an amine, then you could also have that substituent at N, because there would only be one nitrogen as your amine. So this would be a cyclohexanamine, and we would have the substituent at N. So N-ethyl, because the ethyl group is located on the nitrogen. Cyclohexanamine. The numbers are unnecessary for where the amine is on the cyclohexane ring because we only have one substituent, so therefore it could be anywhere. We by default put it at 1, but you don't need to indicate that. This is the same way we've done it for any cyclic functional group. So a cyclohexanol doesn't need a number, a cyclohexanone, things like that don't need numbers. Anytime it's on a linear chain, like this one up here, you need a number to indicate where it's going to be. If it's the only thing on a ring, you don't need to worry about it because it's just coming off of any place. All right, the priority for these, you may recall that at this point what we have covered is aldehydes, ketones, alcohols, and amines fit right below alcohols. And then we go down to alkenes, etc. So this is a C double bond O. This is a C double bond O. This is a C single bond O. This would be a C N, and this would be just a bunch of carbon bonds. So you can kind of track this according to the periodic table. We've got 2 bonds to an oxygen, 2 bonds to an oxygen, 1 bond to an oxygen, and then 1 bond to a nitrogen, and then we move down to our carbons. So it kind of goes in the order of electronegativity. So oxygen before nitrogen, nitrogen before carbon, but also 2 bonds before 1 bond. And that's kind of how it works out in general. That's not a hard and fast true because rule because alkenes come before alkynes. But in general, the priority is going according to the highest number of bonds to the most electronegative elements. All right, so what happens if you have both an alcohol and an amine on something? So if you have this one and this one, then the amine would need to be a substituent. So as a substituent, the nitrogen or the amine is written as an amino. So for instance, if I had a molecule like this one, let's make this a little bit bigger, and I had my alcohol over here, then my main chain would be including the highest priority functional group, which as you can see up here, the alcohol is higher priority than the amine. So the amine would be a substituent, and this methyl group right here would be a substituent. When you number, you always number with the highest priority group at the lowest position. So I would number from the left to make the alcohol at the lowest place. So the main chain of this would be a hexanol, a 2-hexanol. So that's my main chain, and my substituents would be a 4-amino and a 5-methyl. And I'll put those in alphabetical order. Amino would come first, so 4-amino, 5-methyl 2-hexanol would be the name of that molecule. All right, I've got one more thing here, which would be complex substituents. Complex substituents is something that we have done before. But what if you had, say, this molecule? I'll put a ring on there. I'll put on a nitrogen with an ethyl group. So let's just go with that one right there. So the highest priority functional group, looking at our list, the highest one that we've done is aldehyde. We don't have one of those, but then ketone would come next, and we do have a ketone. So the longest carbon chain that has the ketone on it would be this chain. So you'll notice that over here we don't have this rule about including the N as a location. That only works if the nitrogen is part of your main chain. In this case, the one that we've just drawn, the nitrogen is not part of the main chain. So what we would have here would be a complex substituent, where you have an ethyl group on the nitrogen and the nitrogen on the main chain. So we do need to number this. Right? Our main chain would start with 1, where our ketone is, 2, 3, 4, 5. So the substituent here would be an ethyl amino, because the ethyl group is coming off of the amino. You don't need to number the nitrogen, because if you have an ethyl group on an amino, there's only one place it could be, since the nitrogen is only ever one nitrogen. So we would have an ethyl amino as a complex substituent. Ethyl amino. And it's good form to put this in parentheses. It's not always done, but I feel like it's always helpful. That's at position number 3 of our main chain. So 3 ethyl amino. Again, ethyl comes before amino because the ethyl group is on the amino and the amino is on the main chain, right? Ethyl on the amine, amino on the main chain. We always go from furthest away to closest in. And then the name of the main chain there would be cyclopentanone. And I will come around this way. Cyclopentanone. I got that from the fact that this was a cyclopentane. And you drop the E and replace it with "-one" to name the ketone. Once again, we didn't need to put 1 cyclopentanone because the assumption is, just like we did over here, your highest priority group on a ring, and only on a ring, is always at carbon number 1. There are 5 amine-containing ringed compounds that you just need to know the name of. The first we've seen before, which is the benzene ring, essentially, that has a nitrogen in it. It's aromatic, but it's not benzene. Benzene is, of course, all 6 carbons. This is 5 carbons and 1 nitrogen. This one is called pyridine. Pyridine. Another one that we have seen before is an actual benzene ring with an amine attached to it instead of part of it. And this one is called aniline. So hopefully those ones are not brand new to you. But here's some that are. So if this one is pyridine, it's an aromatic compound with a nitrogen attached in it. A 6-membered ring with an amine that is not aromatic. This would be a non-aromatic ring. This one is called piperidine. So those are the 6-membered aromatic and non-aromatic rings that contain amines. There are also 5-membered aromatic and non-aromatic rings that contain amines, which are this one, 5-membered aromatic ring, and this one, which is a 5-membered non-aromatic ring. The aromatic one is called pyrrole, Pyrrole, and the 5-membered non-aromatic one is called pyrrolidine. So it might happen or help to notice that these are all kind of PYR names, or more or less. There's the pyridine and the piperidine. Then there's the pyrrole and the pyrrolidine. So I know that the names are pretty similar. The PYRR starts off the 5-membered rings, so hopefully that'll help you to differentiate them a little bit from each other. And of course, aniline stands alone. All right, so those you just need to commit to memory. I don't have a good trick on those. These are actually IUPAC names, so those are some that you just need to know. All right, so for class, I would like you guys to try to name these molecules. And these are culturally significant molecules. You can look up, you might know what they are. Hopefully you don't know what they are, but that's okay. I'll tell you what they are if you don't have the curiosity to look it up yourself. So see if you can name that guy. And also, here's a very similar compound. These two compounds are very similar, but their naming will be quite different. All right, so see if you can name both of those, and we will go through that in class. Have a great day.